Hi everyone, it's Coach Fred here, and today we're going to be moving on in polynomials, and we're going to be talking about writing polynomial equations from graphs and tables. Okay, so for me it's really important, remember, that we can do different things with a function. So we want to be able to look at a function using the rule of 4, graphically, as a table of values, as an equation, and verbally. Okay, so with these graphs of polynomials, it's really important we know what happens at the zeros and we know what the end behavior tells us about the function. So if I'm looking at this first function from a graph, I'd love to be able to write a polynomial. So I really want to look at the end behavior, which here is up, down. So that tells me that my polynomial is an odd degree, okay? I see that it's got an x-intercept here at -2. So I'm going to write that as a factor, which would be x plus 2. Remember the opposite. And it takes a bounce there. So that's going to be a degree 2 polynomial, or degree 2 binomial. All right, it also has an x-intercept here at 3, which goes up, which goes down. So that tells me that at x minus 3, it's going to have a degree 1. So it looks like this is a degree 3 polynomial. Okay, now remember, all of our functions have an a term. Now the a could be 1, but as we did with quadratics, you can now use other information on the graph to find a. So we're going to use that y-intercept point of 0, 24, and I'm going to plug it in to find a. So 24 equals a, 0 plus 2 squared, 0 minus 3 to the 1. All right, 0 plus 2 is 2, 2 squared is 4. So I have 24 equals a times 4 times -3. And I wrote that as -13. Sorry about that. Okay, so that's going to give me -12a equals 24. So a equals -2. So my polynomial, either with you writing it with y or f of x, I'm going to write it with f of x this time, is going to be equal to -2 x plus 2 squared and x minus 3. Now, at the beginning, I knew it was negative. Why? Because it was up, down. Remember, if it were positive, it would be down, up. And I want you to always think about what your helper graph is with these polynomials. This was an odd degree, so I like to use y equals x. Well, y equals x goes like this, and y equals -x goes like this, which is up, down. So that's just something that I kind of use to help myself. All right, so how am I going to do this with a table? Remember, a table gives me really specific points, and I want to look carefully at points that have zeros in them. So when the y is equal to 0, we know that it is our x-intercept. So I have 3 x-intercepts here. I have 1, 0, I have 5, 0, and I have -8, 0. All right, well, there's no way for me to know what's actually happening at those x-intercepts, so I'm going to assume that they have a degree 1. So I would write this as x minus 1, x minus 5, and x plus 8. So we're going to assume 1, and we're going to give our a term. All right, now we have this other point on the graph, -2, 6. Let's plug that in. 6 equals a. Okay, so -2 minus 1 is -3. -2 minus 5 is -7. -2 plus 8 is 6. Ooh, that's yucky, isn't it? So that gives me -18 times -7, which is 1. I'm sorry, I can't multiply today. 8 times 7 is 56. 7 times 1 is 7 plus 5 is 12. Negative times negative is positive, so that gives me 6 equals a times 126. Okay, so then I'm going to divide by 126 and simplify, and that gives me that a is 1 over 121. All right, so my final equation would be going to put it up here. Y equals 1 over 21, x minus 1, x minus 5, and x plus 8. All right, hopefully that was a helpful video. Have a great day.